Assignment electromagnetic effects in the doubts question 16 and 17 now. Question 16, the diagram and the photograph shows a moving coil loudspeaker. The moving coil loudspeaker, what happened? Fine thin wires are there which are placed in a magnetic field. So there's an AC current. That AC current produce a magnetic field which interact with the magnetic field of a permanent magnet, and the wire will experience a force continuously. The direction of the force changes as an AC current, which cause a vibration in the wire, and that's how it produces a sound. So loudspeaker contain a coil connected to a cone that is free to move. The coil is in radial magnetic field. Radial magnetic field means like the magnetic field is pointing in the direction towards the center or representing a radius. And you can see when the current start to flow through this wire, like the current is flowing through the wire, so direction of a magnetic field and the direction of current are perpendicular. So explain why, even though the wire is not straight, the force on the wire of a single turn of a coil can be calculated by using a formula F is equals to. So this formula F is equals to BIL is only valid when the wire is perpendicular to magnetic field. Because what happens, all the points, the direction of the magnetic field is changing. Like it is directed towards the center, but it is all as it is directed towards the sensor. So all the points, you can see the direction of a magnetic field is perpendicular to the wire. That's why we can use this formula F is equals to BIL. Not F is equals to BIL sine theta. Why? Because sine theta in that case, if the wire is making certain angle. But in this example, the wire is always perpendicular to the magnetic field, or the current carrying conductor is always perpendicular to the direction of magnetic field. So the formula will always be F is equals to BIL. Then calculate the force acting on the coil, which is having a 120 turns. So the diameter of the coil is given. So we have the formula F is equals to B, the force on the wire, that is given by formula F is equals to BIL. And we don't have to use sine theta because all the position the wire is perpendicular. Strength of a magnetic field is 0.8 Tesla. The current is 0.11. Then what about the length of the wire? Because this length of a wire is actually the circumference of the circle. Because the total length of a wire, which is the for L means the total length of a wire which is placed in a magnetic field. Because it's a circular wire, so what is the total length of a wire which is placed in a magnetic field? That is equals to circumference, that is 2 pi r. Or if we don't, if we know the diameter, radius, instead of radius, if we substitute diameter, so it will be d by 2. Or we can also say pi d, because radius will be d by 2. When we substitute here, it will become pi d. So we get the circumference by using a formula pi d, or it is 2 pi r if radius is there. So diameter of the reason they give the diameter of the coil, so we can work out the length of a wire placed in a magnetic field. So F is equals to BIL. B is the strength of a magnetic field, 0.80 Tesla, multiplied by current 0.11, and then we can say pi d. The most of the, as you can see, most of the question, the lengths are in centimeters, so you have to convert. Don't forget to convert it to meters. So 0.045. But how many turns? 120 times if this wire has turned. So for one turn, this was a length. Then multiply by 120, so that will be total length. So when we multiply all of them, we'll get the force on this wire, which is about 1.5 Newton. The next part, an amplifier unit can be used to amplify the music from devices with a small speaker. Like example, smartphones are there, such as smartphone. It amplifies amplifier unit. There is a coil connected to an amplifier and a loudspeaker as shown. So smartphone is placed on the amplifier unit so that the coil of the smartphone speaker is above the coil of the amplifier. Basically, it's like a mutual induction. Mutual induction means like change in magnetic field of a, like there's a current in one coil produce a magnetic field. And due to change in magnetic field, the EMF induced in the secondary. And it's like a step up transformer. So what happened? Like there's a current in the smartphone coil, the speaker. When there's a current, there is a magnetic field of this coil. This magnetic field, the amplifier coil is in a magnetic field of the coil of smartphone. And due to, because it is continuously changing the current, so there's a continuous change in magnetic field, and that change in magnetic field produce EMF for current, and that amplifier unit increase that current and produce a loud sound. So it is like a transformer, working of a transformer. Explain how the music played by the smartphone is also played through the loudspeaker in the amplifier unit. So what are the points you will mention here? The first thing, that there's a varying current in a smartphone coil, or there's a change in, like always, these coils, they are working on an AC. So there's a variable current. So there is a variable current in the smartphone coil, which produce variable magnetic field. That is one thing. And due to that variable magnetic field, there is a change in magnetic field or magnetic flux in amplifier coil. As a result, what will happen? It induce or produce EMF. And the complete circuit allow the current to flow in the loudspeaker, and which produce the sound. So this is what actually happens. Like the amplifier units are working. When you place a smartphone, the smartphone speaker is producing a sound, as well as there's a change in magnetic field in the change in current in the smartphone speaker coil. As a result, that change in magnetic field produce change in current produce change in magnetic field. That magnetic field cause an induced EMF in the amplifier coil, and when the circuit is complete, the current start to flow and the loudspeaker will produce sound. In question 17, the photograph shows an electric motor. This is an electric motor made by placing a strong circular metallic magnets. You can see magnets are there with the like poles facing each other at either end of a dry cell. So there is a dry cell. You can see there's a dry cell, and there are permanent magnets. Here, where identical poles are there, these are the magnetic, how the magnetic field are like this, because like poles repel each other. So as a result, the pattern of a magnetic field which it will produce, if you remember, like if I have south and north, and I have north and north, so they try to oppose each other. So this will be the magnetic field pattern produced between the like poles. Same thing happen, that because these like poles produce a magnetic field pattern, in the same manner as the two magnets facing each other, but the only difference, the direction will be inward. So this will be the magnetic field lines due to the magnetic field of the two magnets. And the conventional current is there, which is from positive to negative. So current is perpendicular to a magnetic field that experience a force. And when it experiences a force, it will rotate. So this cell will start to rotate due to the force. Explain why the motor start to roll when the place in an aluminum sheet. Basically, like when we place an aluminum sheet, now the circuit is complete. As the circuit is complete, so there will be and this is a metallic. So what is the direction of conventional current? The current start to flow. So you can see the current is perpendicular to the magnetic field. As a result, when the current is perpendicular to the magnetic field, there will be a force on the object, and that force is actually causing a rotation or a turning effect. So the points you will include, what will happen when we place this on the aluminum sheet? So there's a current in the aluminum because the sheet is making a complete circuit. So there is a force on aluminum due to the current, which is perpendicular. And the motor, so according to Newton's third law, look, this one, when the current is there, because according to Newton's third law, action and reaction forces are equal but opposite in direction. So when the current is passing through a wire, through a material, the material experiences the force. When we work out the direction of force, our index fingers point in the direction of magnetic field and second represent the direction of the current. So where thumb is pointing, so it means thumb is pointing downward in this case. So if the force on the aluminum is downward, what will the force on the motor? It will be, or force on the magnet, it will be upward. Because according to Newton's third law, action and reaction for if due to a magnetic field, there is a force on the object will also exert force on the material. So what happened? Why it start to rotate? The points which we will include. The first thing, there is a current in aluminum because the circuit is complete. That's first point. Then there's a force on aluminum which is perpendicular because the current is, so there's a force on aluminum because the current is perpendicular to magnetic field. And when there's a, so there will be equal and opposite force on the motor from aluminum. So there will be opposite force, equal and opposite force on motor, and on the motor, the forces will be unbalanced. So when the forces are unbalanced, the object will move or rotate. So forces are unbalanced. That's why this motor will start to rotate. In part B, to determine the magnitude of the force acting on the motor, the aluminum sheet is placed at an angle to the horizontal. As you can see, this aluminum sheet is there, and like to determine the magnitude of the force on the motor, this aluminum sheet is placed. This is aluminum sheet which is making certain angle. The motor is positioned to roll, and the angle is varied until the motor does not roll up. Like forces are balanced now. The motor remains stationary when B is being raised 2.1 centimeter and the length of the sheet is 7.9. So like this is 2.1 and this length is 7.9 centimeter. Both measurements are made using a ruler marked in millimeter. So compare this method of determining the angle. Compare this method of determining the angle of about 1.5 degree to measure the angle with a protector. So first, because the protector is about like it can measure about 1 degree accurately. So first, what we will do, we will work out this angle. Like this length is 7.9. It's a right angle triangle. So this is 7.9 and this one is 2.1. So if I want to determine this angle, theta, so this one is perpendicular, this one is a hypotenuse. So sine theta is perpendicular divided by hypotenuse. So if I need theta, that is equals to sine inverse perpendicular, which is 2.1 divided by hypotenuse is 7.9. What's the answer? It's not 7.9, 79. Not 7.9. 2.1 divided by 79 and take a sine inverse. How much is this angle? So this angle is 1.52. So if we use example, if we use a protractor, what is the percentage uncertainty? Percentage, like example, because the question is both measurements are what we did, the motor remains stationary when B has been raised to 2.1 and the length of a sheet is 7.9 centimeter. And both measurements are made by using a meter rule or the ruler in millimeter, and compare this method of determining the angle of about 1.5 to measure angle with the protector. So if we measure the angle with protector, it will have very high uncertainty because the percentage uncertainty will be the protector, the value recorded. Example, a protector is 1 degree, smallest value, divided by value recorded into 100. So using a protector, it will have a very high uncertainty. But when we use this method, like we measure the length 2.1 centimeter, and using a meter rule or a scale, the uncertainty, like smallest value which can record, is 0.1 centimeter. So what is the uncertainty in measurement of this length? So 0.1 divided by 2.1 into 100. How much is this? 0.1 divided by 2.1 into 100. What's the percentage here? 4.76. Okay. So this is 4.76%. And how much is the uncertainty in measuring 79 centimeter? So 0.1 divided by 79 into 100. What's this percentage uncertainty? 0.1 divided by 79 into 100. What is the percentage uncertainty in this measurement? 0.12. So 0.12%. So 4.67% plus 1.12%. So what is the total uncertainty? It is about 4.88%. So in measure total uncertainty in this measurement is about 4.88%. Compared to when we use a protector, we'll have a very high uncertainty, like because it's 1 divided by 1.52 into 100. What is this uncertainty in the measurement of the angle if we use a protector? 1 divided by 1.52 into 100. 65.8% uncertainty. So you can clearly see that this method is suitable instead of the protector. So because it's having a lower uncertainty. So you just have to compare the two methods. If you use the protector, you will have a very high uncertainty. As a protector, the least count is 1 degree. So the least uncertain percentage uncertainty is the uncertainty divided by value recorded into 100. So second method of measuring the height will give a more accurate result as compared to using a protector. So just have to compare the results. Then show that the force exerted on the motor is about 0.02 Newton. Mass of a motor is given in gram. So if this motor is stationary, means there is no resultant force acting on this motor. So how we can work out the weight of this motor is acting downward. So the weight is there, that is acting downward. And how we first we can work out the weight. And this weight will have two components, W cos theta and W sin theta. Like remember on inclined surface, whenever we have the object on inclined surface, so if there's an object on inclined surface, its weight is acting downward. So here is an angle theta. So the weight will always have two components. Like when we take an axis, this will be theta. So one of the component with an angle W cos theta. And another one is W sin theta, which is causing an acceleration to the downward acceleration. So W sin theta is in this way. So same thing. If this angle is theta, sorry. So on inclined surface, when we take the axis, this angle theta is same as the angle of inclined surface. So weight will have two components, the one which is with an angle W cosine theta, against the angle will be W sine theta. And this W sine theta is balanced by the force which is opposing the motion. Like there's a force which is opposing the motion. So this force is in this direction, F. The force due to the wire placed in a magnetic field, current carrying conductor and an object placed in a magnetic field. Because it is not accelerating in the on the like it is stationary, so we can say the F is equals to W sine theta, where W is equals to mg, so mg sine theta is equals to F. We just substitute the values. M is the mass of the motor, which was given in gram, so you have to convert into kilogram. So divide by 1000, so 0.0694, gravity 9.81, sine and the angle is 1.52. So we work out the force it will experience. That is 0.0178 Newton. So this is the force which wire will this will experience due to like, because the idea is that at a certain angle the W sine theta will balance with the force on the wire when it is placed in a magnetic field. So this wire or the motor will not move, or it will remain stationary, or forces are balanced. Then the next part, determine the magnitude of a magnetic flux density. Magnetic flux density means the strength of a magnetic field, B. Through aluminum sheet, assume that the magnetic field is uniform along the length of aluminum sheet between the magnets. The distance between the magnet is 7.4 and the current is 3.4. So we have the formula F is equals to BIL. Magnetic flux density means we need B. We already worked out the force in the previous part, that was 0.0178. B, we don't know. I is the current which is passing through 3.4. And the length of a wire, as you can see in the image. So this was the length of a wire which is placed in a magnet. Because the force on the motor, the question is we want the strength of magnetic field. The idea is that because the two forces will be opposite in direction, same in magnitude, opposite in direction. So if the force on the motor, when we calculate it, it was 0.0178. So this force will also be 0.0178. So we have the force, we dimension the current, and dimension the distance between the magnet, that is the length of the wire. So length of the wire is 7.4 centimeter. We convert into meter, so 0.074. We just need B, so that will go there in division. The final answer will be 0.07 Newton. 0.07 Tesla. Because that's a magnetic flux density, so that should be in Tesla. Or you can also say Weber per meter square. So 0.07 T will be the final answer.